Hello everyone. Our project is environment sound classification using deep neural networks. We are a group of 3 members. Mainly, our project focuses to develop a system capable of classifying environmental sounds using deep neural networks. The system will analyze audio recordings from various environments and categorize them into a predefined class. Basically, we have used a dataset called Urban 8K dataset. This dataset consists of 8,000 sounds. Uh, mm, the system will analyze audio recordings from various environments and categorize them into predefined classes. Uh, the dataset consists of 10 classes. That means 10 different types of sounds. For example, dog walk, gun firing. The system's effectiveness will have significant implications for wildlife conservation, urban planning, and public health. The motivation behind our project stems from the critical role that accurate environment sound classification plays in various domains. For instance, in wildlife conservation, identifying species based on their sounds can aid in monitoring populations and accessing ecological health. Similarly, in urban environments, classifying noises can inform city planning efforts and mitigate noise pollution's impact on public well-being. Environment sound classification can provide valuable insights into ecosystems, including the presence of specific species, anthropologic activities, and natural phenomena. Gathering a diverse dataset of environment audio recordings covering a various sound sources, environment, and conditions. This dataset may include recordings of animal calls, human activities, machinery noises, with weather patterns, etc. So, the main objectives of our project are accurate classification, deep develop deep learning models capable of accurately classifying the environment sounds into predefined categories or labels. The primary objective is to achieve high classification accuracy across a wide range of environmental sound classes. Real-time processing. This objective is crucial for application requiring timely monitoring and intervention, such as wildlife conservation, noise pollution management, and emergency response. Robustness to variability ensure that the classification model can robust to various variations in the environment conditions such as background noises, change in recording equipment, and various in sound propagation. Robustness enhances the reliability and applicability of the models in diverse real-world settings. Scalability design models and algorithms that can scale to handle large volumes of audio data significantly. Introduction. The classification of environmental sound plays a vital role in various domains, including urban planning, wildlife conservation, and acoustic event detection. Traditional methods for sound classification often rely on hard handcrafted features and shallow learning models, which may lack the capacity to capture the intricate patterns present in the environmental sounds. With the advent of deep learning, there have been a paradigm shift towards data-driven approaches that can automatically learn relevant features from raw audio data. In this project, we aim to develop a system for environmental sound classification using deep neural networks. By harnessing the power of deep learning, our system seeks to achieve higher accuracy and robustness in sound classification compared to traditional models. Additionally, we aim to implement real-time processing capabilities to enable on-the-fly analysis of environmental sounds, enhancing the system's usability in practical applications. Right? Prob- Problem statement. Environmental sound classification plays a crucial role in monitoring ecosystems, assessing biodiversity, managing noise pollution, and supporting conservation efforts. Traditional methods of manual classification are time-consuming and impractical for analyzing large volume of audio data. To address this challenge, the project aims to develop and deploy deep neural network models capable of automatically classifying environmental sounds with high accuracy and efficiency. This project addresses the need for automated environmental monitoring and analysis. By accurately classifying environmental sounds, it can assist in tasks like biodiversity monitoring, urban noise pollution assessment, and environment impact studies. Mm, We have we have read various research papers uh, to know how did they do such type of project. Um, First paper is done by PISAC. The study explores various CNN architectures and processing techniques for future extraction from spectrograms achieving state of the art performance. Second paper is from Smith. This study focuses on urban noise classification using targeting environmental sound methodology and future extraction approach and discussion existing solutions. Several existing solutions addresses environmental sound classification using deep neural networks. Here is an overview of some notable approaches and systems. Google's machine learning for environment audio recognition. Google developed ML here, a deep learning-based system for environment audio recognition. It can detect multiple sound events within audio recognition. It has been applied to various environmental monitoring tasks. TensorFlow audio recognition tutorial. TensorFlow, this tutorial demonstrates how to build and train a deep learning model for environmental and sound classification using TensorFlow and Keras. Urban sound dataset and channel. The urban sound dataset is widely used benchmark dataset for environmental sound classification. Such it consists of audio recordings from urban sounds, example car horn, gunfire, street music, etc. Disadvan- Disadvantages of existing models. Dependence on Google infrastructure, limited customization, scalability. These are the disadvantages. Proposal solution. Firstly, we have collected data and processed it. The dataset we have used is 28K dataset. Uh, we have maybe 8,000 sounds. In those, which 6,000 sounds are used to train the dataset, train the model, and remaining 1,500 sounds are used to test the model. We have used various extraction techniques such as MFCC, mel frequency spectral coefficients, to represent the frequency content over time, and mel spectrogram, model architecture design. Next, design a deep neural network architecture tailored for environment sound classification, learning convolutional neural network CNN for feature extraction and temporal modeling. Experiment with different CNN architectures, including variations of residual networks, dense networks, and attention mechanism to capture relevant features and dependencies within the audio data. Training and optimization. Divide the dataset into training, validation, and test sets. As I said it before, train the deep neural network using the trained data. Employ optimization techniques like is SGD, stochastic gradient descent with momentum and learning rate scheduling. Next, model evaluation and validation. Evaluate the trained model using validation datasets, calculate metrics such as accuracy, precision, recall, and F1 score to access classification performance. Validate the generalized capability of the model on the on-chip data. Implementation result. We have tested the model by giving a random sound from the dataset uh, to the model to predict from what sound it is. As you can see, there is an output called dog bark. We have given a random dog barking sound and asked the model to predict what class it belongs to. Uh, it predicted dog barking, and this is the confusion matrix we have constructed for the results. And this is the Melspec program, feature one of the feature extraction technique, and we have constructed training and validation loss. The blue color curve is represents training loss, and uh, the orange color curve represents validation loss. We have constructed ROC curve for true positive rate and false positive rate respectively. In conclusion, we summarize the project's achievements, emphasizing the significant advancements in Environmental sound classification using deep neural networks. The proposed solution for environmental sound classification using deep neural networks presents a comprehensive approach to address the challenges and limitations associated with the existing models. By leveraging advanced techniques in deep learning, data pre-processing, and model optimization, the solution aims to overcome issues such as data dependency, computational complexity, overfitting, and interpretability concerns. Additionally, the strategies to handle environment variable resource constraints and ethical considerations are incorporated to ensure the robustness and scalability and ethical soundness of the solution. Thank you.